Welcome to the lecture on decision under risk and uncertainty. Third lecture, we will discuss in this class about the expected variance decision making. Basically, as we know, these are the statistical parameters which are used to know how much accurate you are predicting. So, basically in the earlier lecture we had calculated the expected values by taking the probability values of every options into account, and we calculate the expected values or the mean values, and based on that we have to decide which of the alternative should be selected. But many a times the mean values alone cannot be the decisive factor, because we can come to a situation where the mean values does not differ much. In that case, the variance of the variable must be taken into account. Basically, there is more realistic representation of uncertainty when the variability is taken into account. So, we will see it by solving an example which will show that how variability can tell us more accurate prediction and we feel more confident in representing our results. Let us see one example where it is written that the probability distribution of realizing present worth from three mutually exclusive projects P1, P2 and P3 developed by a company are as follows. So, basically you have the three projects and you can have these present worth values and the probability associated for getting suppose present worth of 15 lakhs is 0.3. Similarly, probability associated with P1 for getting 30 lakhs of present worth is 0 and so on. So, basically you have three projects and the probability distribution is shown for this, which will yield this corresponding value of present worth. Now, in this case, as we will proceed, we will find first the expected value or the mean value, but then we will also find the variance, and then we will see that how you can predict the results using expected value as well as the variance using each probability distribution. So, let us solve this question. Now, what we see is that if you go using expected value, what we see is, you see that you have 15 lakh and for that your probability with first project is 0.3. So, if you take for project P1 expected value, it will be nothing but 15 multiplied by 0.3 plus 30 multiplied by 0.0 plus 45 multiplied by 0.1 plus 60 multiplied by 0.2 plus 75 multiplied by 0.2 plus 90 multiplied by 0.2. So, this comes out to be 4.5 plus 0 plus 4.5 plus 12 plus 15 plus 18. So, 33 plus 45 and plus 9, so it is 54. So, if we get the expected value of 54, then let us see for project P2. For project P2, in the similar fashion we can get the expected value. It will be 15 times 0.1 plus 30 times 0.2 plus 45 times 0.3 plus 60 times 0.1 plus 75 times 0.1 plus 90 times 0.2. So, this much comes 1.5 plus 6 plus 13.5 plus 6 plus 7.5 plus 18. So, 31.5 and then 45, this is 51 and 52.5 lakhs of rupees. Let us go to the project 3. So, for that the expected value will be P1. So, that will be 15 multiplied by 0.1 plus 30 multiplied by 0.1 plus 45 multiplied by 0.2 plus 60 multiplied by 0.3 plus 75 multiplied by 0.3 plus 90 multiplied by 0. So, this will be 1.5 plus 3 plus 9 plus 18 plus 22.5. So, this is 54. Now, what we see is, using the expected value criteria, we get the expected values for the project P1, P2 and P3 under the given probability distribution. We get the expected value as 54, 52.5 and 54 lakhs. So, certainly we will prefer this and this, but then since they are matching and you will see that it will be very close. So, it is advisable to go for the checking of the variability, and for that we will find the variance. So, based on this values we will find the variance. Find variance. Now, for finding the variance we will use the formula. Variance will be equal to expected value of present worth square minus the value of present worth and its expected value and its square. So, we will find the variance for project P1. For project P1, the variance will be, we have this 54 lakhs, but we have the 15 lakh individually for this probability. So, first of all we will get the expected value of the square of these values. So, we will have 15 square into 0.3 plus 30 square into 0 plus 45 square into 0.1 plus 60 square into 0.2 plus 75 square into 0.2 plus 90 square into 0.2. So, we will have the values like this: 225 multiplied by 0.3, and this will be subtracted with the value of expected present worth, which is calculated as 54 lakhs. So, it will be subtracted from this amount. So, this is coming as plus 0 plus 2025 into 0.1 plus 3600 into 0.2 plus 5625 into 0.2 plus 8100 into 0.2 minus 2916, and this we can compute using the calculator. Sorry. So, this will be 67.5 plus 202.5 plus 720 plus 1125 plus 1620 minus 2916. So, this is coming out to be 819. So, this is the variance for project 1. Let us see the, so in this fashion we have to calculate the variance for all the projects. Let us calculate variance for project 2. So, let us write here, we have the expected value project P1 as 54 lakhs, P2 as 52.5 lakhs and P3 as 54 lakhs. We have got expected variance, we are calculating, and for project P1 it has come out to be 819. Now, we will calculate for P2 and P3. So, for P2 again it will be 15 square multiplied by 0.1 plus 30 square multiplied by 0.2 plus 45 square multiplied by 0.3 plus 60 square multiplied by 0.1 plus 75 square multiplied by 0.1 plus 90 square multiplied by 0.2 minus, we have to get the square of this expected value, that is 52.5 square. So, this will be equal to, we have 225 multiplied by 0.1 plus 900 multiplied by 0.2 plus 2025 multiplied by 0.3 plus 3600 multiplied by 0.1 plus 5625 multiplied by 0.1 plus 8100 multiplied by 0.2 minus it will be 2756.25. So, we can further add them. So, it will be 22.5 plus 180 plus 607.5 plus 360 plus 562.5 plus 1620 minus 2756.25. So, it is coming out to be 596.25. What we see is that although P1 gives 54 lakhs of expected value and P2 gives 52.5 lakhs, the variability in terms of the parameters known as variance, 819 is for the project P1 and 596.25 is there for the project P2. Let us calculate for P3. For P3, variance will be 15 square into 0.1 plus 30 square into 0.1 plus 45 square into 0.2 plus 60 square into 0.3 plus 75 square into 0.3 plus 90 square into 0 minus the expected value was 54. So, its square value and that is 2916. So, we have 22.5 plus 90 plus 405 plus 1080 plus 1687.5 plus 0 minus 2916. We can get this value. It will be 22.5 plus 90 plus 405 plus 1080 plus 1687.5 minus 2916. It is coming out to be 369. So, what we see is that project P1 was giving us the expected value of 54 lakhs, P2 was giving 52.5 lakhs, P3 was giving 54 lakhs. So, we could have preferred P1 and P3 instead of P2. However, it is difficult at this stage which one to decide, whether P1 or P3. So, in that case it is better to go for the variance studies. Once we calculate the variance, what we see is for P2 it comes 596.25 and for P3 it comes as 369. So, it is seen that the variance value of P3 is the minimum. In that case, P3 should be preferred. So, we can say that since expected values of project P1 and P3 are same at 54 lakhs, the variance value for P3 is smaller than P1. Basically, it is smallest of all, so P3 should be preferred, should be the preferred choice. So, basically, this is how, when you have this type of cases where the expected values are nearly equal and you have the difficulty in deciding which one should be preferred, in that case this method of getting the variance and seeing that where the variability is minimum, it gives you that you are more likely to be close to this value. In this case the variability chances are less, so that is why it should be the preferred choice. Next we will discuss about one of the technique when these type of elements are very uncertain and there are many components. In that case, one of the technique which is very much known, that is known as Monte Carlo technique, that is also used. We will somewhat discuss in brief about this Monte Carlo technique, how it is used to find these values. So, basically the Monte Carlo technique this technique is used under the cases when you have to decide and there is chances of risk and uncertainty, and if there are many elements and there is large amount of uncertainty, in that case this Monte Carlo technique is used. Now, in the Monte Carlo technique basically we use random numbers which follow some kind of probability distributions. So, basically in the Monte Carlo analysis you have first to generate the random numbers. Now, let us say when suppose the time period is not certain, you have by and large you know time period may be 1, 2 or 3 or 4 years, and the probability of having this time period is suppose 20%, 30%, 20% and 30%. Then you have, there are two possibilities of suppose present worth. You may have the present worth either as 40,000 or 70,000 and its probabilities also are given like maybe 60% and 40%. Now, under these cases when you have more components involved and the probabilities are involved, in that case you have to take the effect of both and then you have to proceed. Under these cases the Monte Carlo technique, because in otherwise it will be very complex and further you have to move. So, under these cases Monte Carlo technique is a preferred choice. So, in this basically you generate the random numbers. Now, random numbers are generated based on this probability distribution. So, you can generate the uniformly distributed random numbers and you can see that you can have you can generate random numbers. Now, in this case, if you are generating a random number between 0 to 100, basically you will generate the random number between 0 to 99. There are 100 random numbers. So, if this is 100%, you can generate the random numbers from 00 to 99. So, what happens? You will generate the random number, and random number, since it is 20%, so from 00 to 19 will be the random number which will be assigned with the time period 1. Similarly, for 30, so another 30 numbers will be assigned for this, so it will be 20 to 49. Then another 20 will be for 3 years, so it will be 50 to 69, and another 30, that is 70 to 99. So, this way you can assign the random numbers to these values. Similarly, in this case also you may assign the random numbers. So, random numbers will be from 00 to 59 and 60 to 99. So, this way you can assign the random numbers for these cases. Now, what you can do is generate uniformly distributed random numbers. So, there are many generators of the random numbers. You can generate it using the Microsoft Excel, or you can generate the random numbers following certain rules or following certain typical probability distribution functions by the random number generators. So, basically, for example, when you will generate the random numbers, you will have, so once you generate the random numbers, suppose it comes like this: 17, 83, 42, 9, 5, like that it may go. So, basically you can generate the numbers, and you can take the number, the first number, suppose 17, and 17 will come. So, for first case you will take the time period as 1 year. The second one as 83, at that time you will take the value as 4 year. So, for every reading you will go with, similarly the random numbers, if you are going for 100 random numbers, the range will be 0 to 59 here and 60 to 99. If you have a scale of 10, in that case 0 to 5 and 6 to 9. So, any of the ranges can be taken, and once this random number is coming according to the random number generators, so we can do the iteration, and iteration wise if we go, you can take the year based on the random number. So, whichever random number comes, suppose 17 comes, so you will take the year as 1. Now, you will take the random number for the present worth value, and present worth value, if you are taking suppose the 10 base and the first number comes 7, in that case it will be 70,000. So, first number suppose comes 7, in that case the present worth will be 70,000. So, this way whatever calculation you have to do, you can further do and get the results. So, you can calculate the values. Now, this will basically be continued for a long time, so that you come to the place where the variability, because as long you go you take larger and larger range of random numbers, and if you continue to go for more distances, the chances of getting the errors is minimum, and in that case you can calculate whatever you have to calculate. So basically this is one of the technique which is to be used, and it is quite worth to know about the technique. This is very useful for calculating the cases when we have many elements, the uncertainty is there in all these elements, and you have to take into account the effect of the uncertainty of more number of elements. In that case the calculation can be done. Thank you.